During our tutorials, we will use the interactive environment called Colab Notebook from Google, which allow us to write and execute our Python code without any setup or configuration. Just use your Google account, access to the website colab.research.google.com, and you can create your first notebook. In this video, we will discover Pandas, which is one of the most important packages for the data scientist. It's built on the NumPy package, and it allows you to store and manipulate tabular data in rows of observation and columns of variables. Pandas deals with 3 data structures, but let's focus now on 2 of them. Data frame, which is a 2-dimensional labeled data structure with columns of potentially different types, and series, which is a 1-dimensional labeled array capable of holding any data type. First of all, we need to import Pandas as PD and NumPy as NP. Let's start by creating a random NumPy array with the shape of 6 rows and 6 columns, and including integer values from 0 to 10. Then we create 2 lists. The first one stores the row names, and the second one stores the column names. And finally, we can create our first Pandas data frame using a data frame method and assigning the previous arguments, which are the NumPy array, my array, the list row names as index, and the list call names as columns. As you can see, our data frame is tabular data that provide the exam grade of each student. The index of this table is the list of students, and the columns is the list of courses. If we check the type of df1, we get a data frame, which is a 2-dimensional data structure. But if we check the type of one column, it returns a series, which is a 1-dimensional data structure. There is another way to create a series and data frames based on the dictionary. The dictionaries are written with a curly bracket, and they have keys and values. We can use the pd.series method to create a column sport and assign as argument a dictionary. In our example, the keys are students and the value are the type of sport. We can do the same operation to create a new series which specifies the sex of each student. And finally, we can use the previous series to create a data frame by using the data frame method and assign as arguments the dictionary, which includes the name of the column as key and our previous series as values. Now we have 2 data frames, df1 and df2, with similar indexes. Let's try to merge these 2 data frames using the pd.merge method, which needs at least 4 arguments. The first data frame df1, the second one df2, and we set the parameter left index to true, which tells Python to use the index from the left data frame as the join key, and we do the same for the parameter right index. If you want to access to a specific column, there are several ways to do it. You can put the column name between the square bracket like df sport and you get the series sport. Or you can just type the data frame name dot the column name like df.sport and you get a similar output as the previous one. If you type a double square bracket, you get a data frame instead of series. If you want to get the list of the column names, you can use the case method or the columns attribute. You can also access the list of the index by using the index attribute. If you want to get all the values of your table, then you can use the values attribute. It's also possible to do a quick check if a specific column name exists in your data frame. For instance, you get true by typing course2 in df.columns. And you get false for the column test, which is not existing in your data frame. In Pandas, you can select rows and columns by index number using iloc. The indexes before the comma refer to the rows, and those after the comma refer to the columns. In this example, we select a subset of the first 3 rows and the first 7 columns. You can also select rows and columns by their names using loc. In this example, we select a subset of the rows between student 1 and student 3 and all the columns between course 1 and sport. It's also possible to filter according to certain criteria, like returning only the students who got a grade higher than 5 in course 2. If you want to sort the data frame such that the course 1 will be displayed in ascending order, then you can use a sort values method. Note that unless specified, the values will be sorted in ascending order by default. With Pandas, you can print out the different summary statistics per column, like the minimum, the maximum, the mean, standard deviation, and so on. In our example, we only apply this method on the first 6 columns which have a numerical data. For the categorical variables, you can use the value counts method in order to get the count of the unique values. For example, df.6.valueCount returns the 2 unique values, female and male, and their frequency count. The describe method plays a very critical role to understand the data distribution of each column. It's used to generate descriptive statistics like percentile, mean, standard deviation, etc. Let's now try to create some missing data in our data frame. By using the replace method, we can replace a list of values by np.none, which stands for missing numerical data. And now let's deal with the missing data. In order to detect missing values, we use isNull method, which returns a data frame of booleans. In other words, we get true of the null values and false for the non-missing values. If you would like to count the missing values in each column, then you need to add a sum method. To get the total summation of all missing values in our data frame, we chain 2 sum methods together. There is still a lot to learn about Pandas, so I propose to continue in the next tutorial. Thanks a lot for watching and see you soon.